The AP Calc AB exam is in 4 days. This series will cover everything, 1 unit per video, and no wasted time. The first video I'll be making is on limits and continuity. The AP Calc AB exam is in 4 days. This series will cover everything, 1 unit per video. The first video I'll be making is going to be on limits and continuity. So what is a limit? A limit asks what value does f of x approach as x gets infinitely close to some number a. And we can denote this as limit as x approaches a of f of x is equal to L. Notice that the limit does not ask for what the f of a actually equals. The function does not even have to be defined at a, and the limit only cares about the behavior nearby. Next, we have one-sided limits. The limit exists if and only if both sides agree. So, in math notation, we can denote that as the limit of as x approaches a from the left side, which is denoted as this minus sign here on top of the a, f of x. This has to equal to the right-hand limit, so as x approaches a from the right side, as denoted by the plus sign here. Both of these equal to L. And only then can we say that limit as x approaches a of f of x is equal to L. If the left and right-hand sides give different values, there is no limit. This shows up constantly on the FRQ. Then we have the properties of limits. You can add, subtract, multiply, divide limits term by term, as long as you're not dividing by 0. So for limit division, we can say that the limit as x approaches a of f of x over g of x is equal to the limit of f of x over limit of g of x. Of course, provided that the limit of g of x is not equal to 0, because you cannot divide by 0 even in this case. And then a common exam question is, when you plug in a, you could get an indeterminate form or undefined form, such as 0 or 0. Obviously, that's not the answer, but what do we do here? For example, if you take like limit of x approaches 3, for example, x squared minus 9 over x minus 3. When you plug in 3 to the numerator and denominator, you'll get 0 or 0. So in this case, you can factor it actually. Limit as x approaches 3 of x minus 3 times x plus 3 by the difference of squares divided by x minus 3. Here you can cancel out the x minus 3, so it'll just leave you with the limit of x plus 3 as x approaches 3. This is equal to 6. So we cancel and plug in every time. Now for rational functions at x approaches infinity, then only the highest degree term matters. So limit as x approaches infinity of 3x squared plus 5x, for example, divided by 7x squared minus 1. Then we don't care about these terms, 5x and negative 1. We only care about the highest degree term, which is the quadratic in this case. So when the top and bottom have the same highest degree term, this is the ratio of leading coefficients, so it becomes 3 over 7. Basically, if the top degree is greater than the bottom, the limit is plus minus infinity because the numerator dominates. If top is less than bottom, the limit is 0 because the denominator dominates. And now we come to a crucial section of the AP Calc AB exam. Continuity. A function is continuous at a if all 3 of these conditions hold. So the first condition is if f of a exists. The second condition is if the limit of f of a of f of x as x approaches a exists. And the third one is if limit of f of a of f of x is as x approaches a is equal to f of a. If any one of these failed, that means there's a discontinuity. And the three types of discontinuity is removable, which is going to be looking like there's a hole in the graph. For example, here, there's a hole, so it's not continuous here. Or you could have a jump discontinuity, which is right here, there's a gap in the middle and goes here. So you jump from here to here, and this portion is not continuous. And the third one is just an infinite discontinuity. So basically that means you have a vertical asymptote. So if you have it here, then the function approaches here. And then the next section is called IVT, the intermediate value theorem. Now, IVT is crucial for the FRQ portion, because in many FRQs, they'll ask you to justify why a solution exists. In this case, we want to cite IVT and state continuity. So IVT states that if f is continuous on the interval AB, and f of a is less than k, some constant k, or takes a value between f of a and f of b, then we can get that there exists some c that belongs in the interval AB such that f of c is equal to k. So this can be used to prove why a solution exists in a certain interval. Next is a less common but still useful theorem for AP Calc AB called the squeeze theorem. Now the squeeze theorem might seem a bit complicated, but it's really not. If you have three functions, if g of x is less than or equal to f of x, is less than or equal to h of x near a, and then we have the limit of g of x is equal to the limit of h of x equal to some number L, then we have the limit of f of x must also equal to L because it is squeezed between these two values that are the same value. So this can be useful when you want to deal with some oscillating functions such as sine of x. You know that sine of x oscillates between 1 and -1. So this could be used to bound some functions, such as the limit as x approaches 0 of x squared divided times sine of 1 over x, this is equal to 0. Because here you can see that since sine of 1 over x oscillates between 1 and -1 due to the properties of a sinusoid function, then you can have the absolute value of x squared sine 1 over x is going to be less than or equal to x squared. So we have 0, because you can just plug in 0 to here. And then there are two key limits you should get yourself familiar with. These are the trigonometry limits. The limit as x approaches 0 of sine of x over 1 over x, this equals to 1. In the same way, it can be bounded. So 1 over x times sine of x. And then cosine is limit of x approaches 0 of 1 minus cosine x divided by x equals to 0. You should have both of these memorized as they appear often each year. So this unit and this video covers limits and continuity. And I will soon drop the next video covering derivatives and integrals. So please subscribe if you don't want to miss the next video, and you got this.